Let's try it again. So, polynomial means, poly means many or a lot. You'd be able to recognize it if I wrote a polynomial on the board. Okay? It really just means an expression with many terms, pretty much. Now, it is a little more to it than that. Polynomials can't have any negative exponents. Polynomial expressions can't have any rational exponents, like these fraction exponents, none of those. It can't have any variables in the denominator. There are certain restrictions, but roughly translated, a polynomial is just something with a lot of terms. So let's just get through this first objective real quick so we can spend some time on the important stuff, factoring. So give that one a try. The magic choosing pen. Who's going to come up to the board? I don't write much on the board here. I write on this board. You guys are the ones that write on this board here. Who's it going to be? We can either have a volunteer or a voluntold. Come on, be brave. This is somewhat of an easier problem. You want to try it? All right, thank you, Mr. Brave. Write the answer down. Isn't that cool? You can write on the board. Yeah? Oh. Okay. Thank you. What do we think? Alright, I agree with the 3x to the fourth. There is not another x to the fourth term over here, so that term's good. Negative 3x to the third. I agree with that because you're supposed to distribute this minus sign to all three of those, so it becomes negative 3x to the third. Minus 4x squared, that's good. Now, where'd the plus 14x come from?
Well, since it's a minus, you're going to multiply that with 12x, making it a positive 12x.
So this becomes positive 12x, good?
Adding that to the 2x.
Plus 2x makes 14x. All right, and negative 8 stays negative 8. Nice! That's just one where you have to be careful with your arithmetic. Not too much involved here. Let's try harder. Let's do a multiply. And we're going to move beyond just the multiplying two binomials. Let's do a binomial with a trinomial. Now, when I'm using these words, binomial, trinomial, I'm going to start to use more mathematical terms. What do you think I mean when I say binomial? Two terms. So trinomial would be three terms. So this right here, what is that? Trinomial, trinomial, tri means three. If I say monomial, that's one. Is that still a polynomial, you think? Kind of weird. It is. A monomial is a type of polynomial, but it only has one term. I know it's strange, but a monomial still technically is. Let's do 2x minus 4 multiplied by 3x to the third minus 8x plus 2. Let's try that one. We have this one we probably ought to show a little bit of work on. Come on now. You can do it. You want to try it? Awesome. Tell me your name. Rachel. Okay. So I'm trying like this, you want to erase it, hold the button down. Erase. All right.
That was so cool. I love Pre Calc. It's like my favorite show.
So what do you guys think? You don't think anything?
If that's right, I forgot. Yeah.
Let's see. Now, right here? Okay, okay. This is an interesting way to set this up. It works. Setting it up like this will work. Here's an alternate way of thinking about it. This way is great, but if you wanted, who is familiar with the FOIL method, as some teachers call it? You can use an extension of the FOIL method here. If you just go multiply here, then multiply here like that, and just making sure that you do all of the multiplication. It's just a different way. It's not a better way. It's not the right way. It's just a different way. 2x times 3x to the third would give you that 6x to the fourth term right there. 2x times negative 8x, negative 16. X squared, then 2x times 2 is 4x. That would be the multiplication by 2x. Now you distribute the negative 4 and get negative 12x to the third, plus 32x minus 8. And then usually you are going to end up with some like terms here, so we get a 6x to the fourth. Let's see. Then we have this negative 12x to the third. And we have this minus 16x squared. And then, yeah, the 32 and the 4x there should have been a 36x minus. So is that what you were talking about there, the 36? Yeah. Man, you were pretty dang close. That's pretty awesome. That's all right. So, I mean, this is the way I do it. I just do an extension of the FOIL method. This is called, some people call it the box method, where they kind of line things up. They're both great any way you want to do it. Just got to remember to keep track of like terms and such. Now, let's try this one. This is a special, they call this a special product. There's not really anything special about it, but they just call it a special product. What about something like 3x minus 4 squared? I want to go over this one particularly because I see a very common mistake, very common, and don't feel bad if you kind of have this tendency. You cannot distribute the exponent. You cannot do it. You cannot distribute the exponent into the parentheses. Okay? Now you're saying, well, sometimes we can, and you're right. Didn't we do a warm-up question that was it was kind of like this? It was like 2x squared y to the third. Didn't we do one like this? Here we did distribute the exponent. Because this is just one term right here, because they're all multiplying. What's the difference with this problem? It's two terms. It's a binomial. You cannot distribute an exponent into a binomial or a trinomial or anything like that.
So you're going to have a 3x minus 4 multiplied by 3x minus 4.
Yeah, is that what you were saying?
Yeah.
That's one way you can do it. One way that you can do this is just to do 2 of these 3x minus 4 quantities, and then use the distributive property or the FOIL method. That's a fine way. There's a little shortcut. You guys like shortcuts? They're only good, though, if you can remember it accurately. If you only remember half the shortcut, then you have a shortcut. Anyway, that doesn't even make sense. Here's a shortcut. If you're squaring a binomial. Now, I'm using some pretty fancy words. Do you understand what I mean by squaring a binomial?
Yes.
This is a binomial, right? So if you're squaring a binomial, you square the first term. So what do you get there? 9x squared. Okay? Then you multiply these two terms together and then double that. So you multiply the two terms together, then double it. Negative 24x, right? So you're going to get negative 24x. And then you square the last term. That's a little shortcut for squaring a binomial. If you want to try to remember that, great. If not, just remember that you have to do 2 quantities, 3x minus 4 times 3x minus 4. That's about all we need to do for multiplying or adding or subtracting polynomials. I think you guys can handle that pretty well. Let's move on to the factoring. I think this is going to take a little more time. Gesundheit. Before we do that, why don't you guys let me factoring. Oh, you're gonna be getting enough of factoring that you're gonna be sick of it by the end of this. Not just today. This is gonna be a reoccurring nightmare.
Recording, right?
Yes. Thank you. All right. So there's different types of factoring we're talking about. We're just going to start out with something easy, factoring out a common factor. So here's example. What example were we on? Only example 2. Wow. Factor out the common factor. So 8x to the 4th y squared plus 6x to the 3rd minus 2x y to the 4th plus the 4th root of 6 pi ei. I'm totally kidding with that last part. I was just kidding with that last part. I know. That'd be funny. And the whole time I'd just be sitting there thinking, ass suckers. Maybe. True. Well, I guess I should specify. You want to factor out the greatest common factor. I need to be a little more specific. Factor out the greatest common factor, because there might be a few common factors, but one of them, only one can rise to the top. That's the greatest common factor. There can only be one victor. 100%. I would break this down into smaller chunks. First, look at each coefficient. You know what I mean by coefficient? Coefficient are the numbers. What's the biggest number that divides into each of those? 2. So 2 is going to be part of your greatest common factor. So here's what we're going for. We're going to have some kind of an expression outside of a giant parenthesis. The common factor goes outside the parenthesis. What's left over stays inside. Do you understand the direction we're headed here? So we know that a 2 comes out from the coefficients. Now let's just move on to the x variables. At least how many x's does each term here have? They all have at least one x in common. So we're going to factor out an x. And how many y's do they all have in common? This has a y squared, that's a y squared. So they all have at least 2 y's. We can factor out a y squared. Now, we have to write what's left over. Factor out means dividing, you guys, dividing. So 8 divided by 2 is 4. We took away one of the x's, so that's x to the third. And we took away both of the y's, so we don't have any y's from there. Plus 3x squared y minus, now we took away the 2, and we took away the x, y squared. Cool, right?
Why does it have an extra y?
Where?
Right.
Because this term right here
No, are there two y?
came from this term right here, right?
Oh, that's a 3. Okay, we're done.
Yeah, yeah. Okay, let's try, this is going to be a little more, well, I was going to say unorthodox. It's a normal problem, it just looks a little strange. See what you can make of this one. Now, well, before you get too far into the wrong path, do we necessarily need to distribute the x squared over the negative 4? I would not. I know the first impulse when you see something in front of parentheses is, oh, distribute, get rid of it. I wouldn't do that here. Okay? Maybe we should, let's go over this one together. This, this right here is one term, okay? We have this factor multiplied by this factor, and this is one term. This is a second term, so really, I know it looks funky, but this is a two-term expression. We have this term and this term. What factor does each term have in common? Each term has a 2x plus 5 as a common factor. You guys seeing this? You can't cancel them out, but you can factor it out. If I factor out a 2x plus 5 and a 2x plus 5, I'm going to factor out that common factor right here. 2x plus 5. I factored out that common factor. What's left over now that I factored out the 2x plus 5? X squared minus 4. Now, let's stop here and make sure we're on the same page. Oh, here? Yeah, they both are 2x plus 5. So both terms have a 2x plus 5 factor. Hey! They keep you taking care of it. So both terms had a 2x plus 5 common factor, so we factored that out from both terms. Read it as a common factor. That left an x squared minus 4. Now, you may not be familiar with this, but this actually factors a bit further. Raise your hand if you're familiar with the phrase difference of squares, the difference of squares. If not, okay, but it's something you need to become familiar with. Difference of squares. Difference means subtraction. Difference means subtraction. These are two perfect squares. This factors into x minus 2, x plus 2. That factors into 2x plus 5. Now, I know this one was a bit of a stretch. This may or may not have been taught to you last year in Algebra 2 or College Prep. Well, you'll see a lot more of this difference in squares pattern, so hopefully you'll get more used to it. Okay? But this is fully factored. 2x plus 5 times x minus 2 times x plus 2. Okay. Yeah, that's fully factored. These next couple of problems are even probably more important that you can do very well. This is something for those that are coming out of Algebra 2 and College Prep. This kind of factoring here is something you ought to be able to do with your right hand tied behind your back, blindfolded. Factor the quadratic expression. We'll start off easy, get a little bit more difficult. So here's an easy one, x squared minus x plus, x squared minus x minus 42. X squared minus x minus 42. Now again, it's okay, I know we're coming off summer, you might be a bit rusty, that's fine, don't start panicking. But once you see the process, you should immediately say, oh yeah, I remember that, no big deal. These are easy. Okay? What I mean that you're supposed to be doing here is writing something in this form. Your answer should look something like this. Two binomials. Light bulb. Right? We haven't had a volunteer. Anybody want to impart their wisdom for us? You want to give it a go? No? Hey! What do you guys think? We should do like this the old Roman times. Thumbs up or thumbs down. Thumbs down is no good. You know what happens with thumbs down, right? Yeah. What do you guys think? Is there a way to check this? You could multiply it back together using the FOIL method. Now, I'm completely okay for those that can just rattle this off without showing much work. There isn't a lot of work to be shown here. I am going to show you the method that really is happening here, because this is the method I would like you to become used to when we get into Chapter 3, which I'm just warning you ahead of time is a horrendous chapter of the book. Probably the most difficult one of all. You always start these problems by multiplying the leading coefficient with the constant. 1 times negative 42 is negative 42. We now need to find two factors of negative 42 that add to the coefficient of the linear term negative 1. And that happens to be positive 6 and negative 7. Right? Now you're going to say, oh, this is the long way. For this problem it might be, but for other problems this is the way that it needs to be done. Okay? Once you've come up with these two numbers, you split the linear term into the sum of those two numbers. So you have x squared plus 6x minus 7x minus 42. Okay? We've gone from a trinomial to how many terms here? There's 4 terms. It doesn't really have a fancy name. It's just a polynomial with 4 terms. I don't know why they ran out of creative names. But anyway, once it has 4 terms, you factor by grouping is what this method is called. Okay? If you haven't seen this method before, this is something that you probably ought to write down and put a box around, because we're going to be doing a lot of this factor by grouping method. What comes out of this first group as a common factor? X. That leaves you with x plus 6. What comes out of the second grouping here as a common factor? Negative 7. And that would leave you with x plus 6. Doesn't this problem look slightly familiar? We did a problem like that up here, right? This one had a binomial as a common factor. This one has a binomial as a common factor. So you factor out the x plus 6. That leaves you x minus 7. Okay? So maybe for this kind of a problem, that's a long way. But you are not going to be able to get around not knowing this method in the future in this course. You have to be able to factor by grouping. Okay. Let's try it on a little more difficult scale here. Part B. Excuse me. 6x squared plus 7x minus 5. All right, then. Want to give her a go? All right, so far so good. Press the button down. And it turns it into the eraser. Cool, huh? Perfect. Very good. Very good. Now I wanted to bring something up that at sometimes, not all the time, but sometimes I see a little bit of confusion. This right here, some students would look at that and say, "Well, God, there is no common factor." But you can always divide out something from everything. 1, right? You can always divide out a 1. So if there doesn't appear to be a common factor, you factor out a 1. And in this case, since this term right here is negative, you factor out a negative 1. You can always use 1 as a common factor. Good. Now, question for you guys. Does it matter the order that these two terms come in? It doesn't. It could have been negative 3x plus 10x. It doesn't matter the order. You'd end up with the same thing. Your binomials would be switched, but it's all right. Okay. Well, we kind of already did it, but just some special factoring formulas. So this might be review for some of you. Let me just go over that difference of squares pattern. Special factoring situations. These are going to be good to know, especially for the AccuPlacer exam coming up. So we're going to start with difference of squares. And this is something that's just best to commit to memory. You know, I'm not always a fan of just straight memorizing because that's not everybody's strong suit is memorization. But for some things in mathematics, it's best if you just try to memorize. And this is one of those things. So if you have the difference of two squares, so I'm going to say a squared minus b squared. That's the difference of two squares. The pattern for factoring is a minus b times a plus b. That's the pattern for difference of squares.
For an interruption, can you add that economy to the...
Yeah. So let me just go over the one that we just did a few moments ago. So we have the expression x squared minus 4, right? So, and if you get good enough at this, you don't have to show all these steps or go through all these steps, but you can think about this as x squared minus 2 squared, correct? X squared minus 2 squared. So this becomes your a value, that becomes your b value. That's why the answer was x minus 2 times x plus 2. That's called difference of squares. Again, it's pattern first that you have to be able to recognize pretty quick, and then you have to be able to recall that little pattern or formula, if I guess you want to call it a formula. Sometimes it's not quite as easy to spot. So let's just run through a couple of examples here. Example 3. There's this example 4. 4. So let's do, let's start easy. X squared minus 49. Part B, let's do 4x squared minus 25. Part C, let's do 2x squared minus 18. Part D, x squared plus 64. Yeah. Record. So, x minus 7, x plus 7, right? Gotta be a little more careful on part B. Well, you can always start with just a blank set of parentheses. You know one's going to be minus, you know one's going to be plus. Is there anything that can go here and here, the same two terms that'll equal 2x squared when multiplied together, or 4x squared when multiplied together?
2x.
2x and 2x, 5 and 5. That's one way you can think about that problem. I don't really do it this way. I tend to think more like this. What's been squared here and what's been squared here? So that would be a 2x and that would be a 5. That kind of tells you the same thing. Anyway, you got to be clever on part C. You have to factor out a common factor. If you factor out, very good. If you factor out the 2, then you have difference of squares. These are just little things you have to start to recognize and watch out for. And then part D, not factorable, right? This is not difference of squares right here. Tried to fool you on that one. Be honest, did I fool anyone? So this is not factorable. It's not factorable using real numbers. We could factor this using imaginary numbers. This is actually kind of cool. We could actually think of it like that.
We're kind of getting a little on the fringe here. What do you guys think? Let's just talk about this, though, because this is not something that's outside the scope of this course. We are going to be doing this kind of stuff in Chapter 3. That's why I say Chapter 3 is going to be awesome. What are you thinking? What's 8 squared? 64. I squared is really negative 1. Negative 1 times 64 is negative 64, but when you minus negative 64, you get plus 64. So these two expressions are equivalent. I know it's kind of hard to see right now. We're kind of pushing the boundaries, but
this now could be factored using the difference of squares patterns, x minus 8i and x plus 8i. So it's not factorable on the real number system. It is factorable on the imaginary number system. Anyway, you won't see anything like this on your homework, but that is coming up later in the term at some point. So anyway, that is that.